Hi. First, I'm going to explain what an ion is and how it forms. Let's say we have hydrogen. Hydrogen is element 1 because it has 1 proton. So the proton is what identifies the element. There is the one commonality between every element is the number of protons never changes. Thus, it is the one that identifies the element. When you look at the periodic table, you're looking at elements that are neutral, which means they have no charge. So a neutral atom of hydrogen would have 1 proton, it has no neutrons, and I made this a center, and now we have, this is a shell drawing. It has 1 electron. Thus, this is not charged because the positive charge equals, you have 1 proton equal to 1 electron, and thus you don't have more of one or the other. So there is no charge. Now, how does an element get charged? Okay, I'm still going to use hydrogen. It is the easiest and most important at this point in time. Hydrogen, as we did before, has 1 proton, 1 electron. Now, let's ionize it. So now we have the 1 proton that never changes. It can have more than 1 neutron. It can have up to 3 neutrons, and that will change the mass because the neutrons and the protons are what add up to the mass or the weight of the element that is underneath the element on the periodic table. So now here is our normal hydrogen, uncharged. Now I'm going to charge it. And to charge it, all I have to do is eliminate that 1 electron, and it gets taken by another element. That's basically what happens. So what we have here is a bare proton, which means it has a positive charge of 1. It has no shell. It has no electrons around it. This is what causes acidity. As we tested pH, not last week, the week before. So now we have hydrogen, and to show it's an ion, we put that little plus sign up there. So that means we have a hydrogen proton. No shell, you erase the shell in order to do this. Now there are some elements, of course, that have more shells, and your activity at the very bottom of that chemistry lab, which I'm sorry to say I did not bring home, but I can go through the 2 that will cause the most confusion. Most of you can figure out a neutral atom's number of electrons in the highest shell. But let's go to sodium. I'm going to go to another clean page. So we have sodium, whose atomic number is 11. Okay, so let's draw a neutral atom of it. Notice I don't have a plus sign there. This is in the first column. So if you remember, I told you the first column has 1 electron in its outer shell. The row number will tell you how many shells there will be in a neutral atom. So we're going to take sodium. It has 11 protons, 11 neutrons. First shell can only have 2. So we need to add 9 more electrons. So I'm going to put another shell. And the most the shell can have is 8. 8 electrons. Now, electrons are what are used to form a bond. Now, at this point in time, I have not finished the neutral sodium. I need to add one more shell with one lonely electron. That is not a happy atom. The atom strives to be the most electronically capable and least energy. It's all energy focused. And the electrons are attracted to the protons. Positive is attracted to negative. But when you have an electron shell that only has 1 or 2 electrons in it, that last shell is not the most stable it could be. And what you're going to see with these is that they form ions and then ionic bonds. So now I'm going to say we have sodium with a charge. Now, on that homework that well, it's not homework, but if you want to complete it and send me a scanned copy, you can. We will not have time in lab next week because we are doing the microscope. And that takes up the entire 3 hours. There's a lot of work in this coming lab. So if you want me to look at what you did, you can certainly send it to me. And I will look at it. You can scan it and submit it in an email. So now I want to make this sodium ionized. And what happens is it has a positive charge. So that means, okay, if it had 11 protons and 11 electrons, it has no charge. But I'm saying it has a positive charge. Thus, it has more positive charges than negative charges. Thus, we have to get rid of that final electron. So, we are going to eliminate that last shell and remove that last electron, which will get used by another element. And now we have 11 protons and we have 10 electrons. We have more protons, one more than we have electrons. Thus, we have a positive charged ion of sodium. Now, the lab has K with a plus sign. That's potassium. You can try to do that now. It's identical, except for the number of electrons and the protons and the weight, but none of that really, well, some of that is important. As you can see here, I was looking at creating an ion of sodium. An ion is a charged element. So what happens with chlorine? Let's look at chlorine. Chlorine's atomic number is 17. Now, at this point, chlorine, as it's drawn right now, or shown right now, is neutral. So let's do the neutral atom. So it has 17 protons, 17 neutrons. First shell, 2. Second shell, 8. Sorry, it's so messy. So we have 10. Third shell, we only need 7. So there is the drawing, the shell model drawing of a neutral atom of chlorine. Now in this case, there are 7 in the outer shell. You're not going to lose electrons. There's too strong a charge to take away 7 electrons. They're being pulled really hard towards those protons. So in this case, it's more likely to get another electron. So an example is sodium chloride. Plain old table salt, right? That's what you eat. It's an ionic bond that joined sodium with chlorine. Now, in this case, this is neutral. So what happens? Well, if you go back to the previous page and look at sodium, you know that it loses an electron and it becomes ionized. So we have a positively charged sodium. In this case, the electron will be gladly accepted by the chlorine. The chlorine will take the electron from that sodium. And now we have 17 protons and 18 electrons. We now have more electrons than we do protons. And thus, this element would now be drawn with a 1 negative sign. You could have 2 if it gained 2 electrons, which is possible, and elements can lose 2 electrons. But the outer shell for this would have that extra electron in it. So now, because this is negatively charged and sodium is positively charged, they are attracted to each other. And now we have the 2. This is sodium. This is chlorine. They are attached because of the charge. It's an attraction. The electrons in an ionic bond are given away. There is no sharing of electrons. When an element either gives up or takes on an electron and becomes ionized, and then it forms an ionic bond, it's not sharing that electron. Each of them are charged, and each of them either gained or lost an electron, and because of their overall charge, and in this case chlorine would look like that, and sodium, and the 2 are attracted to each other. Thus, when you are completing this lab, the bottom line actually had one that I did in this example and one that I did not. So I hope you can try to do it because it's an important concept for this chapter to understand. Bonds are critical because in Chapter 3, you're going to be looking at covalent bonds and how they get charged themselves at times. So there's a lot of different bonds. There's about 8 bonds you need to know. And most of them you learn in Chapter 2, but in Chapter 3 you will learn some too. I hope this helps. If you have questions, just email and I will try to get back to you. as soon as possible.